Section 8.1a is about multiplying monomials. We're going to start by defining a couple terms. First, what is a monomial? A monomial is a number, a variable, or the product of a number or one or more variables. In other words, anything that's a number or a letter, or when you multiply numbers and letters, those are monomials. Now, a constant is a monomial that is just a number. It doesn't have any letters with it, so as long as it's a real number, it's called a constant. Let's do some examples down here to kind of give you an illustration of that. I want to look at an expression and tell if it is a monomial, yes or no. So the number is -5, and here this is a monomial. The reason why is because it's a constant. It has no variables with it, but it's a number, and by definition from right here, we say that constants are monomials. The second one is p plus q. Now that's not a monomial, and the reason is because it has a plus sign. Now in this case, the p is a monomial, the q is a monomial, but when you add them together to make an expression, it's not a monomial. Next one is the letter x, and this is a monomial because it's a single variable. And from the definition, a variable is a monomial. How about this one? C over D. Well, it looks like it should be a monomial, but it's not. And the reason it's not is because you're dividing. And specifically, you're dividing by a variable. You cannot divide by a variable. You have to be multiplying, which is why the word product is used up here in the definition. And the last one, this expression, you might think that it's not a monomial because of the last one, but in this particular case it is. And here's why. If I multiply 1 over 5 times abc to the 8th over 1, if I multiply those two fractions, all I'm doing is multiplying this monomial times a number, and that's okay. So really all I'm doing is I'm multiplying or finding the product of a number, which is 1 over 5, and a group of variables. So this one is a monomial. Compare that to the one before it, which is not, because you're dividing by a variable. Here we're going to do some more work with monomials to determine if they are yes or no. This first one, is this a monomial? Well, the 5 is a monomial, and so is the 7d. But as soon as you put that minus sign in the middle, it's not a monomial anymore because you're combining two individual monomials with an addition or subtraction sign. So that's a no. This one here, this is also not a monomial, and the reason is because you're dividing by a variable, as we saw in the last example. The last one, n, yes, that is a monomial. And the explanation is because it's just a variable, and that's part of the definition of a monomial. Now we're going to look at an expression, x with a little n above it. This is called a power. Anything that has a little number in the upper right-hand corner, we call that a power. Now breaking this down a little bit, the x has a name. The x, or the big number on the bottom, is called the base, and the number on the top, the little number on the top, is called the exponent. Now what does this mean? I'll give you an example here. If I say 5 with a little 2, the way we say that is 5 to the second power. Or we could also say 5 squared, and what it means is 5 times 5, which is 25. So that's a quick little review of powers, bases, exponents, and so on. Now I'm showing you that because we have a rule here for dealing with powers, and the rule is called the product of powers rule. And here's what the rule says. To multiply two powers that have the same base, now if you're going to multiply these two powers, they have to have the same base, all you do is you add the exponents. That's the rule. And here's what it looks like in general. A to the m times a to the n equals a to the m plus n. Notice I'm multiplying the bases that are the same, but I'm adding the exponents. Here's an example using letters. A to the 4th times a to the 12th is a to the 16th, because I add 4 plus 12. This is how we simplify exponents when we multiply them. So let's try examples here. 5 times x to the 7th times x to the 6th. Well, the 5 is just going to come along for the ride, so really what we're doing is we're multiplying x to the 7th times x to the 6th. And according to the rule, what do? We add the exponents. So this will be 5 times x to the 7th plus 6th. 6 plus 7 is 13, so this is 5x to the 13th. Now, you don't have to write all these steps out. If you can just look at this and say, oh, 7 plus 6 is 13, and do 5x to the 13th, then go ahead and do that. This one's a little more complicated. What I like to do is I like to break it up into pieces. In other words, I'm going to multiply 4 times negative 7 because those are the number parts, the coefficients. Then I'm going to multiply a times a squared. I break it up into that. And then I also multiply the b to the 6th times the b cubed. Because remember, you can only multiply things that have the same base. We said that at the very beginning. So 7 times 4, negative 28 in this case. Here, a to the 1 plus 2. Remember that if you don't have an exponent, we assume there's a 1 there. So in this case, we'll add 1 and 2. And then the b's, we're going to do b to the 6th plus 3, which is negative 28, a to the 3rd, b to the 9th. Here are a few more examples multiplying monomials. These all three have the same base, so I'm going to add the exponents. Remember, there's a 1 here. Plus 4 plus 6 gives me x to the 11th. And then over here, again, multiply the pieces that have the same base. Number times number. Multiply the two a's. And then multiply the two b's. 9 times 4, 36. We're going to add exponents. So this is a to the 6th times b to the 4th. When multiplying bases that are the same, you add the exponents. That's the product of powers rule.